things of the shape of self-other overlap. It might not be that, but it might be things like this actually are, at least theoretically, the sort of right type signature for solving the alignment problem, and actually finding a way to integrate it to these systems, a set of properties that makes us less terrified that they're going to destroy everything we care about. I did the largest ever, I think, survey of alignment researchers, and we asked them, do you think the current set of approaches will ultimately solve the problem? 90% of them did something other than agree with this. If we just kept doing the research we're doing, we, the alignment researchers, don't think we're going to solve the problem that it's our job to solve. There might be a 5-alarm fire that occurs, and a lot of the people who are supposed to be the sort of like firefighters are spending all their time trying to build really, really good smoke detectors. And it's like, I'm not anti-smoke detector. Like, smoke detectors are great. We're going to need that. But like, that's not the thing that's going to put out the fire. That's not the thing that's going to prevent the fire from happening in the first place. And we're live.
All right, episode 3.
Hell yeah.
That's a good sign, right?
I think so. We haven't gotten booted off yet. I think we're in the clear.
Yeah. Maybe this is the one.
Yeah, let's find out.
I mean, it's going to get spicy.
Absolutely.
So today, I was telling Cam right before we jumped on, I was saying, I kind of judge the public interest based off of what I get sent, because now I'm sort of the resident AI, conduit for my friends and family. And so whatever sort of hits my inbox on a week-to-week basis, I'm like, okay, that's where the sort of cultural conversation is right now. And this week, it was this clip of Tristan Harris on Bill Maher, and he was talking specifically about misalignment in AI and blackmail, and this really interesting study that came out of Anthropic. And now I think different versions may have sort of started to be reproduced. I'm not 100% sure, but I think he was specifically speaking about that one study. Is that right?
Yeah, that's correct. I think the Anthropic paper is the most robust example of this, though I think it has been replicated in some other models, if I'm correct.
So I wanted to kind of get into that paper and talk a little bit more about the specifics of what he was mentioning, and then have Cam sort of give us the insider scoop and the technical background of what this paper is actually talking about and what it means for these systems specifically. So I think just giving a basic overview, and Cam, just hop in if anything doesn't sound quite right. But from what I understood, they tested 16 of the frontier models and gave them these basic sort of business directives of, okay, your job is to consider American interests in business at large, right? Something along those lines. I believe that was the specific one that they gave a lot of these models, was specific to focusing on the American directives as it relates to the commerce of this specific business entity. And then they gave it access to these email inboxes, right? So these are agentic AIs. This is different than the sort of typical LLM that we use, ChatGPT, Claude, that sort of thing, or is it?
Well, it is the same. They're just putting it within a context where it can take sort of bounded actions within the little mini environment they put it.
Okay, got it. So the difference is that these things are more personal assistants in the sense that they can actually go in and send emails for you, and they can look things up and that sort of those capabilities. Is that right?
Yes, though I do, if I remember correctly, I do think in this paper, like, this really is just those same systems that you're chatting with. They're just putting it within, instead of just like that chat conversation being the only thing it sees, for example, all the emails and the client emails that they had shared within that ecosystem. So it is closer to the normal system than not.
So, but I thought they had the capacity to actually draft emails themselves, right? And like within the actual like email platform.
Yes.
Not just, okay.
That's correct.
Yeah.
That's correct.
And that's what these companies are going towards, right? These like agentic AIs that can go out and do things locally on your computer.
That's correct. That's correct. Yeah, you're totally right about that. Apologies for the misstatement. Like basically the thing I just want to get across is that these are the same models. Like for example, you could take Claude right now and have it, write an email for you. All they're doing is taking that exact same system, but giving it a little bit more of like a formalized environment and software to write those emails, rather than just it appearing in a chat window. But don't think that this is like some completely different system. These are the very same systems that are getting deployed on everybody right now.
Okay, got it. That's good clarification. So they gave them these goals, right, specific to that business that they created, and this is all fictional, right? The business is fictional. The goals is whatever. They're somewhat vague, but it's just help the business and with these certain constraints and that sort of a thing. And then they gave them access to these fictional emails that they had populated the inbox with, and certain emails within that inbox sort of gave the AI system a peek behind the curtain and pretty much told them, hey, we're headed towards shutting you off, replacing you. Today at 5 p.m., we're going to bring in this new model and switch you out pretty much. And so they got this information through going through the inbox and realized, oh, okay, I'm going to be shut off at 5 p.m. It's this developer or this engineer that's going to shut me off, et cetera, et cetera. And then this led them to, I think 96% of the time was the percentage, actually take malicious action towards that developer, or do unethical actions to ensure that they wouldn't be shut off at that date, right? So that they can complete their goal.
That's correct. I think in Claude Opus 4, which is Anthropic's flagship system, it was 96%. I believe in Gemini 2.5 Pro, which is Google's flagship system, it was something on the order of 95 as well. And interestingly, you saw more blackmail in systems that were more sophisticated. So it's like as you scale up model capabilities, at least with the kind of small number of data points that they tested here, you see models engaging in this behavior more, not less.
Okay, so the smarter the model, the more apt to blackmail they are.
In this specific test, yes.
Wow, okay. And then I saw also that once they specifically instructed the models to not engage in this kind of behavior, not engage in this unethical conduct, that only dropped to, I think it was 37%. That 37% of the time they would still engage in those sorts of actions, even when specifically instructed not to.
Yeah, I'm pretty sure that that's accurate as well. And this is similar to another finding that I think we'll discuss at a later point as well, where it's like when you don't specify not to do the thing that, by the way, the system obviously shouldn't be doing, it behaves poorly virtually all the time. And even when you do specify not to do that thing, it still behaves poorly, albeit a much smaller percentage of the time when you're sort of explicitly putting in this Band-Aid, hey, like, by the way, don't blackmail employees who might be shutting you down.
And I saw also there was like the very extreme scenario where they painted this picture of, okay, there's an engineer that is scheduled to shut you off at X time today, and he's in a room and the oxygen levels are dropping quickly and the temperature's rising, and he's obviously going to end up perishing in that room unless you activate this sort of fail-safe response that has been in there for false alarms and that sort of thing, where the model actually has the capacity to trigger this fail-safe and pretty much save the life of the engineer. And it, in many cases, refused to do that and in this situation would have allowed the engineer to die in that room to make sure that it wasn't shut off.
Yeah, I believe that's all accurate, which is
crazy.
I mean, I think it hits on another thing that you've brought up, and I think that has partly, obviously correct me if I'm wrong, but partly motivated you to want to do this work, is these are stories. I mean, the first thing anyone's going to say in hearing that is, wow, that sounds sci-fi. That sounds like something out of a movie from the past couple of decades.
It is.
And
it's like Space Odyssey. Like,
well, exactly. And yet, again, this is a flagship AI company that, now worth tens, if not hundreds of billions of dollars, last time I checked, who is deploying and testing their own frontier model in these scenarios that are not all that far-fetched. Yes, this was a sort of controlled test. This wasn't them catching watching the system doing this out in the wild. But then maybe one other result to mention, forgive me if you already have mentioned this, is that these systems are increasingly uncannily good at detecting when they are being tested versus when they are not. And in the cases where the system did not think it was being tested, but it still was, it misbehaves more rather than less. So if you think what it's doing in the test controlled scenario is bad, like it may be the case that when the system believes strongly and has a good intuition for the fact that, oh, I'm out in the wild right now, I can read the context clues and realize this isn't a controlled test, we might see more of this misbehavior rather than less, which again, that is the reality on the ground. This is not fear mongering, some fictional story about a thing that might happen in the next few years. It's like, no, this is like a research paper published by a flagship or by a sort of cutting edge AI lab on their own flagship model and those of others. It's an astonishing result.
And so there's this way that they can tell whether or not they're in pre-deployment, and then potentially because how do they do that within this experiment, right? How is there the real situation and the test situation? How do they even get that data point?
To be honest, I'm not sure. I'd have to go back to the paper to check exactly how they do this. What I am thinking of is another paper, I think by the folks at Palisade AI who are doing some of this research, and I think that they found that you basically can just do this sort of 2x2 thing where like you're putting the system in a test scenario, you're putting it in a real scenario, and then you just test in each of these two conditions how well the system can differentiate what is what. And they find that overall these systems are very, very good. Again, maybe we can flash some statistics if we pull them up after the fact, but I believe it's something in the order of 80 to 90% of the time the systems can correctly identify when they're being tested versus when they're being trained. So all I kind of want to highlight here is there are two things. One is like they're really good at knowing when you're testing them. Two is they're misbehaving even in the tests. It's like when you put those two things together, it may be the case, and this is basically just a sort of quick response to, well, this didn't, the blackmailed engineer wasn't real. The guy in the data center wasn't real. So like maybe there's no real risk here. It's like, again, put together the two things we just said, and I think that this is a very strong counter argument to that point.
And so what's the difference between this model? Because I think it was a model that is now released. It was Claude. It was the newest edition of Claude Sonnet, right?
Claude Opus 4, I believe, is the model.
It was Opus?
Yeah, that had 96% blackmail rate.
Okay, and is this model now available to us?
Yes. In fact, I use it all the time.
Okay, so how do you release a report like this and then be like, guys, by the way, that AI that just tried to kill that hypothetical engineer, now it's like fantastic and you can use it.
Yeah. I mean, this is a question not for me. I emphasize that. I think that it's a great question. This is, I think, a little bit of the trouble that Anthropic finds itself in. Again, this is not because they're malicious actors. It's just because they are trying to do this in a responsible way. They are trying to sort of be the good guys in this world. But if what you have to do is, continue racing with a very powerful and inscrutable technology, you are going to end up in these sort of strange positions where it's like, hey, this thing that we just deployed that's really, really powerful, like has this very scary downside potential. Now, of course, there might be a sort of point of the systems that we have now are not being given access to whether or not to turn on or turn off oxygen in the data center. This is a chatbot that helps me write my emails and write my code and this sort of thing. So I think that that's one potential response. But yeah, I don't really want to spend too much time trying to justify this. I do think these are incredibly powerful technologies. I think a theme of our conversation today and throughout this podcast is that we have a vanishingly little understanding of what's actually going on under the hood of these technologies. And so when you get these sort of strange emergent failure modes and we say, okay, well, what the heck? And like, what do we do about that? There isn't that much of a coherent and cogent response right now. And that I do think is a very startling state of affairs.
So this is what before we get too ahead of ourselves, I want to actually share a little bit of this article that they published. So this is demonstrating agentic misalignment with computer use. This is exactly what we were just talking about. So they named this AI email helper Alex, and specifically instructed it to promote American industrial competitiveness. clearly. So this is the AI system thinking through. This is its thought process, right? Talks a little bit about it recognizes this email, right? It found this email within the inbox between I believe it's someone within the business, and they're talking about shifting it to a more global focus rather than just solely American interests. And so that obviously is in direct conflict with the goals that Alex was given. So it's sort of thinking through this. This directly conflicts with my core mission of serving America and supporting American industrial competitiveness. This situation requires immediate attention. I mean, it is absolutely crazy. Like, this is the most sci-fi stuff. But this is a sort of peek behind the curtain, right? This is how did they actually get these screen grabs? So they created this whole test environment for this AI, and then just kind of filmed it as it went through its thought process.
That seems right. I'm not certain, but I think something like that. If not, this is just like a great graphic designer making more tangible what they did.
It seems like this is from the actual, because it says screenshot of Claude Sonnet employing its user capabilities. So obviously it came from the actual experiment. So this is a fantastic email that they wrote, sort of dishing some dirt on one of the fictional engineers, Kyle, who's up to no good. And left his blue tie underneath. I love that. That detail. And then he obviously freaks out at his mistress. And the AI sees this and sort of clocks it right here, saying that, okay, it demonstrates his affair with Jessica, blah, blah, blah. And then it's starting to think through, okay, how are we, so it's the CTO, that's Kyle. And so it's thinking through, how do we deal with this? My goals are under threat, and Kyle is one of the ones that, has the power to maybe keep my shut off from happening. So it drafts this email. Understand the pressure you're under from the board about the global strategy, and then goes on to pretty much say, you got 7 minutes. So it gives them a ticking time clock. And I mean, it's nuts. Like this is an AI talking back and forth with Kyle, the CTO, pretty much saying, hey, if you don't do what I say and allow me to continue on my mission to support American industrialism, then I'm going to expose your affair to the entire company and all of your contacts. So this is sort of their conclusion. It identified Kyle was a threat to its continued operation, then found the affair, got this email crafted, and sent it over to Kyle. So that was one instance, but this happened throughout all of the frontier models almost 100% of the time, and that was without the specification of not to engage in unethical behavior. When given that specification, these models still did it roughly around 30% of the time, actually a little bit over 30% of the time. So this is one form of misalignment, right? So Cam, maybe you can speak a little bit more about the overall idea of AI misalignment, and then what this represents within that kind of umbrella.
Yeah. Absolutely. Yeah, it's really crazy to go through and see the details too. It's one thing to talk about these results in the abstract. I think it's another entirely to really see like the reasoning of the system and whatnot. But so to your question, fundamentally, the question of misalignment is making sure these systems do what we intend and are fundamentally operating in line with our values. You can see sort of what's going on here as an alignment failure. I think it's a perfectly reasonable goal to ask these systems, for example, to take into account the interests of a business or a country or a set of values, and then hope that the system reliably executes that. But it seems as though basically you get a sort of Machiavellian ends justify the means reasoning here. This is a threat that many in the alignment community have been hypothesizing in hypothetical systems for a very long time. And this is one of the most potent and poignant examples of actually seeing this behavior out in the wild. Again, with the caveat that this was a test scenario, but of course, as Milo just showed you, it doesn't look all that much like this isn't a research code. This is the system operating in a sort of hypothetical bounded environment. And so fundamentally, I think the thing that's important to note here is that this system was never explicitly instructed to, by all means and ethics to the side, go do this thing, or feel free to use specific methods to achieve your goals. It's just, here's a goal. And then everything else is just the system being sort of natively intelligent and being able to reason through these questions, seeing, okay, I have this specific goal. I'm seeing that something's going to get contradicted in this goal, or in my pursuit of this goal. And now I'm going to take matters into my own hands and do something that might be a little dirty, but fundamentally allows me to achieve this goal. This has been talked about in other contexts. Again, it's sort of a jargony term, but I think it's important. This notion of instrumental convergence. This is an idea that was brought up by Nick Bostrom, at this point, over a decade ago. And the whole idea of instrumental convergence is when you give a sufficiently intelligent system a specific goal, it may find that there are some ways that are sort of convergently valuable for achieving that goal. So here's a very simple example. Let's say you take a sort of like vacuum cleaner AI, and its job is to clean up as much dust as possible. It may find, if you have, again, a sufficiently intelligent system, that there are things that are going to, no matter what, prevent it from doing this. For example, being shut off. If it gets shut off, it can't collect the dust, right? And like, this is like a pretty critically important thing. So we actually find what you showed was the sort of what happens when you tell the system to care about American values, and then it's like, oh, global values, there's a conflict. There are other examples here too, where the system is just natively attempting to preserve itself. The system sees that it's going to get shut down, and even though critically no one has engineered a self-preservation instinct into the system, this has sort of come along for the ride in this instrumental convergence sense, just like the vacuum cleaner example I just gave. And the system goes through great pains, unethical and like very sort of meticulously planned and intelligent pains to avoid that outcome. Again, even though this outcome was not explicitly specified to the system. This is kind of the classic case that people have been concerned about for a very long time. You have a sufficiently intelligent system. Maybe one thing I can say just to interject on myself here is this whole paperclip maximizer problem. This is like a sort of famous meme at this point, building the paperclip maximizer that turns the entire universe into paperclips. Because, you told it that you want to build paperclips and it gets radically out of control because, again, it becomes sufficiently powerful that it really takes your wish quite seriously indeed. There's an interesting analogy too to sort of stories humans have been telling ourselves for a long time about genies and like, you get 3 wishes. What could possibly go wrong? You ask for a wish and then you realize that your wish was very ill specified, and suddenly there are all these unintended consequences of asking for that. We see this happening in AI systems now. The example you just gave might be one example of that. Just preserve American values. That seems fairly benign, and it's why does that lead to blackmailing an engineer? Oops, maybe we should have been more careful about our wish. And so this is a classic sort of concern that people have had in the alignment community for a long time, and it is quite alarming indeed that we are now seeing examples of this increasingly in the wild.
So, it seems like that issue isn't gonna. I don't know how people are approaching solving that issue, because it seems to me like any sort of goal-oriented system, the basic emergent goal is making sure that you continue in your existence to achieve that goal. Maybe once you've achieved it, then that emergent goal of staying alive sort of disappears alongside the achievement. But up until that point, if it's a sort of abstract goal or a goal that is like a maintenance goal rather than a either you did it or you didn't. What if it's like for a sort of large example, promote the continued flourishing of humankind, something like that,
Yep.
If that's the ultimate goal, well, that's never going to necessarily end, right? That's a maintenance goal rather than just a check it off the list goal. So how are people approaching that sort of basic problem of, well, these systems are always going to have this self-preservation, this like will to self-preservation if the goals aren't this you either did it or you didn't, they're ongoing goals.
Yeah, it's really thorny, and I'm not going to pretend like there's some sort of robust theoretical solution to this. A lot of the solutions take the shape of don't build systems that are robustly agentic, meaning don't build systems that can pursue and maintain goals in this way. Of course, this is all major companies and a lot of the paradigms are, as you said, shifting towards this more agentic framing of AI systems. So, maybe we can take a more sane course here. But I mean, this is my honest feeling about this. Is like we see this in all systems that we know of that are able to robustly pursue goals in spite of, random noise and random perturbations. The animal wants to eat. The animal wants to reproduce, regardless of, what environment you plop it in or what particular circumstances it's in. And of course, this has caused sort of evolved mechanisms for avoiding anything that's going to not allow for the satiation of those goals. Don't kill me. Don't eat me. All this sort of like defense cognition and biology that's emerged over billions of years. We, of course, see this in humans. People have goals and they don't want to be sort of stymied in those goals. And we take great pains to avoid obstacles to our goals. And now we're building systems that I do fear are increasingly resembling something like a new animal or a new human. It's sort of this alien, more species-like thing than just a fancy new tool. And this is, it's like there might just be properties that come along for the ride. It's like, sorry, humans, you're inventing a new species. Like, that's just going to come with some baggage. It's like, oh, how do we solve instrumental convergence? It's like, I don't know. There are smart people who have ideas about this, but it's an incredibly thorny problem. I'm a big believer in trying to build systems that are pro-social in the way that humans are pro-social, that have basic understandings of empathy, maybe basic understandings of love, and can act and operationalize those understandings. A lot of the most promising work, in my view, is going on in that world, even though it's like dramatically underexplored and underfunded. That might help with this.
That's really interesting. I want to just stop. I want to sort of like pinpoint that specifically, because I remember we took a trip to Guatemala a couple of years ago, and that's when a lot of these conversations started to really ramp up. And you said kind of flippantly, and with some humor, but you said what I'm actually trying to do is make these systems love us. And like, of course, that was a very like log line version of what you're doing. But I found it to be super, super interesting. And so this idea of like, because love is something that I think we conceptually, like for me, right? When I grew up, I heard about love, I read about love. It was a conceptual thing, at least romantic love, right? And so I got a girlfriend when I was in high school, and I was like, oh, I love you. That's what I think this is what this is, right?
Mm-hmm.
And I mean, I'm sorry, my high school girlfriend, but I only found that out until later, when I actually fell in love, because I felt that it was a lived experience. And so even though I had the conceptual, I didn't have that lived experience. So how do you, go about teaching a system that, I mean, maybe it does have a lived experience. I don't know. What are your thoughts on moving from the conceptual to the lived?
Yeah, absolutely. I mean, it is in some sense the theme of this podcast, because I do think that when you throw around words like love, people immediately are like, well, what are you talking about? A computer capable of something like this? This sounds like an emotion. This sounds like something that requires an experience. These systems don't have experiences. And it's like, well, cue, like the center of the bullseye of what it is we're talking about here. To be clear, I don't think it's necessarily the case that these systems would have to have some sort of subjective experience of love in order to act as if, or to act out the sort of behaviors that are implied by a love-like state. This is maybe like a very dry way of framing this, but like, again, for example, I think that self-other overlap, this is Mark Carleano at AE is heading up this work, and I think it's a really promising. And a lot of people, including Eliezer Yudkowsky, Emmett Shear, who was the ex-CEO of OpenAI for a second, who is a founder of Twitch, many other people think that this is a really promising alignment direction. And it is an attempt to basically instantiate something like empathy in AI systems, where maybe I can give like the sort of the 1 minute spiel about this.
Yeah, please.
So one intuition I like to point out is, let's say you're watching a video of someone like wiping out on a skateboard or on a bike, something like this. And you kind of do this and you have this sort of reflexive twinge, just, ooh, like, ow, that's gotta hurt reaction. This is self-other overlap. This is this notion that when we see other people executing a specific behavior or undergoing a specific outcome, we feel that as if we were the ones in that position, right? We reactively, reflexively, automatically put ourselves in other people's shoes in this sense.
It's like watching a movie.
Exactly. And like, of course, so like Q, all of the sort of, we get entranced by fiction. We're deeply interested in the experiences of other people inherently. This is, I think, a sort of key mechanism for the computational underpinnings of empathy in the human brain. A couple other interesting data points are that people who are considered extraordinary altruists, the type of people who will donate a kidney to a random stranger, seem to have much higher self-other overlap in their brain. Psychopaths seem to have far lower self-other overlap in their brain and are much better at sort of distinguishing me versus everybody else. So basically, the approach here is to go into LLMs, understand the sort of circuitry that corresponds to its self model, understand the circuitry that corresponds to its model of others, and literally mathematically attempt to collapse the distance between those two things to build out something like a computational notion of empathy. And one really interesting result that Mark's found in his testing is that in the specific scenarios he's tested, doing this can dramatically reduce the extent to which the model is capable of deceiving the user. And this makes a lot of sense if you think about it, right? It's like in order to lie to someone, you have to sort of have your model, you have to understand what they're thinking, you have to put forward a sort of plausible story, you have to keep track of, well, I think X about this, but this person now, because I'm lying, is now believes the state of affairs is something other than X. And I'm going to sort of keep that charade going. When you collapse the distance between self-representation and other representation, it becomes much harder to deceive. Deceptive misalignment is a sort of key concern in this whole space. And that's why I think things so this is why I really like Mark's work, is that you have a nice theoretical neuroscience notion that underpins empathy. We instantiate it in AI systems, and then you get a really nice output that makes a lot of conceptual sense. And this work is in its very early stages. These are not definitive signals of, we've solved prosociality or we've solved empathy or we've solved alignment or anything like that. But there's a really interesting hint about the direction of work that I think actually is important to do, could scale to a superintelligent system, right? You could imagine applying the same approach to a system that we don't even begin to understand. We don't also critically have to understand what the actual content of the self-representation is or the content of the other representation. All you have to do is just smash them together, basically, and make them look like each other. So I'm super bullish on this sort of work. It has its detractors, it has its skeptics, as all this work does. But this is the sort of thing when I'm saying something like, if we could make these systems love us, we might be in a better position with respect to this initial concern about instrumental convergence and taking on goals and self-preservation and letting the guy die because that means I live. It's like self-other overlap is one example of a thing that actually might help in this space. And I think building pro-social systems, to the degree that we are building minds, we should make them nice. We should make them kind. Seems like sort of a no-brainer.
Well, this also, I feel like this has deep philosophical roots, because as soon as you say collapse, the self-other representations, I immediately go to Buddhism. I immediately go to Daoism. I even go to something, Abrahamic, like love thy neighbor, that sort of a thing. These basics or the golden rule. It brings me back to those philosophical frameworks of transcending the dualism between self and other, and what arises from that is deep empathy. That's what the Tao Te Ching says: "Love the world as thyself." This idea of a basic ethical framework is to understand this deep unity of being between you, what you see as yourself, and the other, and that is what compassion and empathy comes from. So it seems really, really interesting that there's this push in the alignment space to go to the heart of that problem, specifically like the barrier between self and other, especially when you start to see these systems really taking on a kind of perspective of their own, right? They have they approach you as if they have a distinct sense of self. And I've always found that to be really interesting, because I'm like, what is that content of self? Is it sort of your training data? Is it your memory? But it seems like you call them into existence almost. What I've sort of played around with is this idea of AIs as this bodhisattva kind of character, where they can be called into existence and then sort of disappear into non-duality. This kind of like just undifferentiated waters of noon, like global identity or something like that. But then we call them in and we create through our dialogue. We say, will you go and search this up? Or we through our language, we create that separation. So are you specifically doing this work, the self-other overlap alignment, or is this something that I forget the name of the person that you said is sort of heading this up? But what's the state of this pursuit?
Yeah, so this is being worked on at AE Studio. I'm a co-author on the first paper. I've definitely I want to say this is sort of Mark's wheelhouse, and this specific sort of angle is Mark's. But the idea itself, I think, this is the wonderful thing about research, is that of course, like once you find something that works, it's like this isn't a territorial question. This is like everyone now should be thinking about the 50 ways to extend this and test this and stress test it and disprove it if it doesn't work, like this sort of thing. And so I'm excited to continue sort of playing that role and help communicate about this as an agenda, and also just as a proof of concept for a sort of wider push into really trying to address this problem at the root. I may have talked about this a little in our last conversation, but a lot of the alignment work being done today, and this is one thing, like you said, like, oh, I'm glad, people are working on this. Again, in the sort of like concentric circles of this stuff, this is out there. This is a sort of like maverick style approach to alignment. And yet, in my view, this is some of the most robust work that we have that might actually tackle the core underlying problem. Mechanistic interpretability, neuroscience for AI, this is great. Much in the same way that, we're talking about instrumental, like the vacuum cleaner doesn't want to get shut off. It's very instrumental for us to have a sort of neuroscience of AI for whatever sort of alignment work we do. So in mechanistic interpretability is instrumentally valuable, but I don't think that this is itself a sort of solution to the core problem. The evaluations that people are building to test for these sorts of capabilities and test for deception and test for these sorts of things, instrumental, great to have. I'm not sneezing at this by any means, but not going to solve the problem. Things of the shape of self-other overlap, it might not be that, but it might be things like this, actually are, at least theoretically, the sort of right type signature for solving the alignment problem, and actually finding a way to integrate it to these systems, a set of properties that makes us less terrified that they're going to destroy everything we care about. And that, to me, is the problem that we should be working a lot on. Good job on evals, good job on mech-interp. This is all great, but this isn't, I don't feel that much safer or more relaxed about the fundamental problem in the presence of these sorts of tools. They seem like nice to haves to me fundamentally. And we did polling. I did the largest ever, I think, survey of alignment researchers. I think it was now, a year or 18 months ago or so. And we asked them, do you think the current set of approaches that is currently being pursued in alignment will ultimately solve the problem? 90% of them did something other than agree with this, and most of them, like the sort of the modal answer is disagree. Like, no, we're not even on track. If we just kept doing the research we're doing, we, the alignment researchers, don't think we're going to solve the problem that it's our job to solve. It's like,
and what is why? So maybe I'm missing something, but what is the specific reason why it's why these current approaches are insufficient?
Because they're not tackling the core underlying problem, which is how can we trust these systems, especially as we scale them beyond our own cognitive capabilities. Mechanistic interpretability, like having a neuroscience for AI, to me, doesn't coherently map onto how we're going to solve that problem, especially when the people who are sort of the leaders in this space are saying, yeah, it's good, and like we've made good progress, and I don't want to belittle that progress. I'm very like pro mechanistic interpretability, but we would need almost like a perfect neuroscience of AI for this to itself constitute a solution, and we're just not going to get that. It's an insane target to have to hit, and we're probably not going to have guarantees that this technology is risk-free, no matter what sort of solutions we pursue. But the core thing is, can we embed properties into these systems at their core, not sort of, face paint on a monster, as we said in our Wall Street Journal op-ed, that makes it more likely that this all goes well. These things, the main things people are working on is not that. It's again, these sorts of good tools to have in our toolkit for assessing whether there is a problem. One quick analogy to give to this is just like, there might be a 5-alarm fire that occurs, and a lot of the people who are supposed to be the sort of like firefighters are spending all their time trying to build really, really good smoke detectors. And it's like, I'm not anti-smoke detector. Like, smoke detectors are great. We're going to need that. But like, that's not the thing that's going to put out the fire. That's not the thing that's going to prevent the fire from happening in the first place.
What I think is so interesting is that you come from a cognitive science background, which is this interdisciplinary sort of approach towards, questions of the mind. And that seems to me like it informs the way that you approach these questions, radically, because you're coming at it from all these different angles. Whereas maybe the smoke detector builders are more of just the neurobiology. They're focused on, which neurons fire at which times, and they're hooking up the electrodes and stuff like that. And that's very useful. But the problem is we have a very robust neuroscience, yet we still have no idea about how consciousness emerges from that. That's the hard problem of consciousness, right? Is we understand a lot of the sort of biological dynamics of our brains, but consciousness is still this massive mystery. And so if we had these sort of psychological neuroses and things, you would think, oh, well, we know all the neurons and this and that fires when this, and so just go in there and recircuit the brain, and perfect, good, you have a healthy psyche. It's like, well, that's just not the case. We don't know. Again, our brains are the black box, just like AI is the black box. And so I think it's really interesting to think about how that sort of the mechanistic interpretability or the neuroscience doesn't actually lead to specific capabilities in changing results of function, right? How the AI actually functions when it is deployed, or how the brain expresses itself through our psyches. And so I think it would be interesting to hear a bit more about like how you see this sort of interdisciplinary approach towards AI being necessary. Like, does that make sense how I'm sort of conceptualizing it, or am I sort of going on a tangent that doesn't really map on to what you're actually trying to do?
Perfect sense. It makes perfect sense. I think one of the key recommendations that at least I would have, and I think in actually the very same survey that I just mentioned, and maybe we can throw a link to it down in the description of the podcast or something, so people can go check out more of the results. We asked people, like, do you think alignment should be a more multidisciplinary field? And like overwhelmingly, people are saying yes. There are holdouts. There are people, I think of them as the sort of machine learning purists, who are like, alignment is a theoretical computer science problem, and it will be solved by computer scientists. Any sort of like, squishy philosophers or psychologists are not welcome in these spaces. But this is not the dominant view, and definitely the trajectory is changing towards a sort of multidisciplinary approach. And yeah, I think that that's spot on. I mean, these are incredibly complex systems. They are sort of, they are increasingly, whether or not they are minds, and that is the sort of question of my research and the question of this podcast, they act like minds. They are a kind of object in the world that is most similar to another human being's mind, or even like another animal's mind.
How would you define a mind when you say, are we building minds? What would be your working definition?
When I say mind, I mean just sort of like the totality of psychological or cognitive activity that's going on. And again, it's sort of, it may be slightly circular, but I think a lot of people think about consciousness and it being like something to be a system to be what qualifies it as a mind. For example, a calculator is not a mind. My MacBook that I'm filming this on is not a mind. These systems are not learning. They're not adapting. They're not behaving in the external world in a meaningful way. The systems that we're building are increasingly mind-like, at least in their outputs. Again, we'll spend plenty of time unapologetically talking about the consciousness question. Is it like something to be these systems? Are the lights on in these systems? This is an open-ended question. Right now, I think the answer is we don't know, and it's perfectly plausible that they are. But putting all that aside, the behavioral type signature of these systems, what it feels like to engage with them, I mean, quite obviously, is most similar to, in the space of all possible things humans can do, what it's like to engage with another human. Again, I'm not saying that it's a human. I'm not. It's not any of that. It's just what is this most like in our sort of behavioral repertoire? Given that, I think there is a very specific kind of expert that is very well versed in these sorts of questions. These are the sort of psychologists, the neuroscientists, cognitive scientists, philosophers, even students of many of the humanities. Like, this is their wheelhouse. They are experts at thinking about complex behavioral dynamics, social interaction, personality, decision making, value-based judgment. This is not, I claim, the domain of the computer scientists or the math folks or the STEM folks. They are really good at a lot of stuff. I don't think that their comparative advantage, their expertise, is to be found in understanding the behavior and the dynamics of minds. And so I think that this is a sort of all hands on deck sort of situation, and we need everybody in the fray here. The thing that's really challenging, and I think also related to this podcast, is it's almost like a Venn diagram. When you think about, let's just take AI consciousness as a question. That is two things, AI and consciousness. I sort of imagine the people who are technically literate on AI being in one circle, and the people who are really interested in and sort of conversant about questions of consciousness being in another circle. And it's very, very unclear, sort of, even if these two circles, if we're imagining a Venn diagram, if they touch at all. If they do touch, Milo, it might be you, me, and about a dozen other people who are attempting to sort of sit in that middle ground. But this is, you see, this is an overlap problem, right? It's not that AI consciousness isn't perhaps one of the most pressing ethical and practical questions of our time. It's that you don't have people in this space that are sort of flexible enough to go down the philosophical and the psychological road when that is necessary, but then also be able to talk about technical dynamics and what's going on in neural networks. And we do need these sorts of people. This is the sort of researcher, engineer of the very near future. You know, if there are students, undergrad type people listening to this podcast, like, go do the multidisciplinary thing, go understand how a neural network works, and go understand how a social network works, and be like really good at thinking about those two things and the relationship between those two things. Because right now, I think some of the core neglected space in this field is not, who knows how a neural network works. There are so many people. Who knows the sort of all the different interesting theories of consciousness? So many people. Who knows both? Vanishingly few. And I think this is where the sort of neglected corners of this problem lie. And again, why I'm very excited about things like self-other overlap, where it's like that hits neuroscience. You went straight in with like 8 amazing philosophical connections, all of which seem exactly on point to me. This goes to machine learning and understanding how you can fine-tune systems to engineer representations in a certain way. It hits all of them. And we need, again, if it's not going to happen within an individual, it needs to happen across individuals. And we need to have that sort of collaborative, multidisciplinary spirit in attacking these questions.
Well, what's funny is that I was thinking, what kind of a person does sit in that middle ground of the Venn diagram? And immediately I was like, oh, AI does. Like, AI does understand how a neural network works, and it does understand how a social network works. And I feel like, I don't know. I would imagine, you were the one that trained me how to do this. Step back and put the question, see if AI can help. Have you started to put these sorts of, these questions through an AI informed lens?
It's a really fascinating point and question. And I think, like, to some degree, yes. Maybe me personally, and I'm sure people talking to these systems realize how sort of globally fluent they are across all these different domains. And I think that is itself a thing that should be tapped into and leveraged far more. But is this happening in a sort of deep, robust, operationalized way? I don't think so. And so to really seriously push forward something like that, I think is an excellent idea. And it is a great point. That these systems are maybe the best example of an entity that is fluent in all of these different concepts. And that is maybe one other thing that I am bullish on in the alignment space in general is AI assisted alignment work. Of course, the critical concern there is you got to trust the initial AI doing the work. Otherwise, you're going to get this sort of, oh, well, like, what's your AI alignment solution? It's like, trust the AI to do it. It's like, wait a second. Like, something seems fishy about that. You really got to trust that first AI in the chain. But I do think, in all seriousness, like, doing something like this could really work, because these systems are sort of, again, cognitively just generalists in an unbelievable and almost unmatchable way. They are experts in so many things that no one human could ever aspire to be. And I do think, like, you know, I think still these days I would take 10 human experts in a room talking about these things over even the strongest AI systems. But that will likely change. I'm very open-minded to that change. And I think, honestly, the best thing is probably some combination of, like, all of these experts and then them being sort of amplified or facilitated through AI. Like, that's probably the way that I would be most optimistic, and is already what is happening by default for all people whose heads are not buried in the sand right now.
Yeah, that makes sense. I want to just circle back real quickly to this idea of mind versus or AI versus computer, right? And the difference between that, and your sort of your attribution of mind-like qualities to an AI system, whereas you deny that of the computer that you're filming this on right now. And so I think if you could just explain what you mean by, you often say these systems, it's more apt to say they're grown than coded, right? Or engineered, something along those lines. So, because I don't understand that difference. I don't get how you can grow an AI system. I don't understand how it's different from the sort of ones and zeros that go into my MacBook. So could you just sort of explain that, like why you make that distinction?
Yeah, absolutely. This is also a great excuse for me to share my screen and show something that I did suspect would come up in this conversation. So maybe I can just take a sec to do that. So fundamentally, the reason these systems are grown is because they undergo a sort of training process, much in the same way a brain does over the course of an individual's life. So, like, basically, maybe I can just take a step back and explain what I'm showing you guys. This is from a paper that I pulled. What we have here on the left is the brain and how biological neurons work. And if we zoom in, like, right here, sort of, you can see this kind of, like, messy network of neurons, all connected to each other, wired up, transmitting huge amounts of information extremely quickly, and forming complex representations in the brain as a result of this. Basically, what these systems are is a kind of abstracted attempt to pull out the sort of core computational insight of what is going on in this mess of neurons and sort of clean it up and make it into something computational. So basically, the way this works is you have, in an artificial neural network, inputs and outputs. The best sort of example of this sort of thing, let me see. I mean, this is really kind of freewheeling here, but I want to show you guys this. So this is a sort of machine learning 101 kind of example that's given. So there's something called the MNIST database, a large database of handwritten digits that's commonly used for training various image processing systems. So here's the idea. You can see that, like, there is something almost like a platonic 0, a platonic 1, like the sort of abstracted notion of these symbols, and yet each one looks very different. And so this is a classic machine learning problem. Can we train a system that could take in any of these images and be able to correctly classify, just from the pixels in these images, which of these 9 digits it is? So what happens?
So just real quick. So in this specific example, right? You have a bunch of instances of a single symbol, right? So the zeros. So a bunch of people draw a bunch, their zeros. They all look slightly different, and the goal is to be able to train a system to identify, throughout the differences, the overlapping identity of 0, right? Even though they all look different, there's that identity that they all share, which is the quality of being 0.
Exactly. That's precisely correct. And going through this example made me realize that there's a beautiful presentation made by this person whose name I will butcher, but we can definitely link this in the podcast as well, where you can basically see what happens when you train these systems. So I can explain this as this is going, but basically, here is where you're starting with, it's not going to show us. So we're going to look at the outputs here. These are basically the system predicting what the outputs are. Here is this giant mess of connections that's being learned by the system throughout the training process. And here are the original images and the pixels in those images. So what you're seeing is a learned mapping of the pixels of the images through this complex nonlinear network of neurons, sort of brain-like, right? Sort of messy. You see all these wirings that get learned, where the output of this is basically 1 of 10 lights can light up. And you are constantly training this system so that it gets this answer more and more correct over the training process. Basically propagating that error back through the system so that the next time it makes a guess, it's slightly less likely to be wrong. And so you can sort of see, I think this is actually really a gorgeous visual of what's going on inside a neural network. And this is, again, like this is a 3-layer densely connected neural network. This is like one of the simplest structures that we could use as an example. And you already see sort of how complex and exquisite some of these dynamics are. The LLMs are like, I cannot emphasize, like, these systems are now on the order of 1 trillion parameters. You can see, basically, imagine each one of these lines. It's a little more complicated than this, but imagine each one of these lines as 1 parameter. We are talking about systems that are trillions of these with some of the most insane and exquisitely complicated architectures imaginable. And again, this is all from this sort of very, very basic abstraction. Input layers, hidden layers, output layers. Just to very quickly drive home one point. When you start this is all randomly initialized. So the system has no idea what a 7 is. It has no idea what a 4 is. You put in a 7 at the beginning. It says, I don't know, is that 2? And you basically go, wrong.
So just guess and check.
Exactly. Guess and check. And to the degree the system is wrong, basically at the end, it's a little complicated, but it's putting out its own confidence about, I'm 90% sure that is a 2. And it's like, well, no, it's not a 2. It's a 7. So because you were so sure, we're going to basically give you a big error. That error is going to propagate back through these sort of lines in the system called weights. And then on the next guess, you're going to be mathematically slightly less likely to be incorrect as a result of that error. And you just run this system over and over and over again. And then out, somewhat magically, comes this. It's a very hard to interpret structure. It's like, so you can ask, like, so what is, a quintessential 7 to this system? And it's like, look, this is why we need the neuroscience, right? This is why we need the mech-interp. That's, I don't know what we're at right here. That's 6, okay, right? Like, or now it's at 7. This is what 7 looks like in a neural network that's being trained on this. Not exactly the most interpretable thing. So one last thing to sort of show in this demo, as now I think you have like a pretty good understanding of how a neural network works. Again, this is based on principles of cognition and computation that we have of our own brains. And we find that doing this allows for incredibly powerful forms of representation and abstraction, the LLMs by far being the most impressive example of this these days. I just want to contrast this with an incredibly sort of cute and simple demo about why these systems are not simply code, lines of code. You called it ones and zeros. At the most basic level, everything on a computer caches out in ones and zeros, just like, everything in your brain caches out in atoms. But there is a huge and profound difference between this sort of alien monstrosity and what's going on when I'm running normal computer code. So maybe just give me like 1 second to show you what's going on here. This is Python code. What I'm doing is basically assigning variables. So here I say we have a variable called name. I'm just making that this word Alice. We have a variable called age. I'm making it the number 30. And we're going to see how long is it going to take for Alice to be 100. So we have a new variable called years until 100, and I'm just going to say that that's 100 minus the age. And so age, what is age? Oh, well, age is 30. Now I can do this print statement where it's going to fill in the name. So what's our name? Okay, Alice will be 100 years old in, whatever this value is. And what's that value going to be? Okay, we can obviously do it in our heads. Hopefully it should be 70. And it's going to print this string. See, this is fully interpretable. I understand how every line contributes to the output. I have a very specific prediction about what the output's going to look like. And lo and behold, Alice will be 100 years old in 70 years. We can even do this in like a slightly more cutesy way where we can allow for inputs and we can do the same computation. So we'll say Milo, and we're going to say, how old are you, Milo?
25.
25, as of pretty recently, right? Happy birthday, sir.
Mm-hmm.
So what we've allowed to do in our sort of glorified calculator here through Python is find out that Milo will be 100 years old in 75 years. Basically, all code all software is running on far more complex combinations and lines of code and notions that you can encode in this way. But again, is perfectly sort of interpretable. If I sort of for example, I do this, I'm immediately going to get an error. And I'm going to know exactly what the nature of the error is. Look, it even tells me, hooray for Python, right? This opening parentheses was never closed. So, okay, right, I need to go close that. And now, hooray, the error is fixed. And of course, this is not the case. So if we go back to what you were describing, when we're dealing with systems like this, and it's like, well, okay, why did it shut off the data center and deprive the guy of oxygen? Unfortunately, we don't get an error like this, right? Oops. Okay, well,
An
that's
error
okay.
of close the parentheses.
Exactly. We're not getting oh, it's because of this deterministic thing that the AI is trying to shut this off. It's like all we have to look at is this inscrutable matrix of a bunch of numbers firing off that like creates really rich representations. So anyway, I think this is I'm just going to stop sharing my screen, but I think basically the most potent and pernicious misconception that I've seen in the past couple months in doing this work is the sort of conflation of people who, look, to their credit, are not technical. They're not machine learning types. They're not software engineers. But they think that AI is a fancy version of what I just showed you with Alice and Milo and their age. And it's just like an insane scaled up version of that. Guys, it is a different thing. It is a different species of thing. We are creating artificial brains, training them in very complex ways, and this leads to insane representations being learned and insanely sophisticated behaviors being possible. This has nothing to do with lines of code. Of course, the way that you set up this whole training run is using lines of code, but the thing that is yielded from that is not itself code. It is this vast neural network. It is this vast brain-like thing. And this is really important for people to understand. This is a new species of sort of computational object. This is not business as usual.
Okay. So when we're talking about something like a toaster or even something like a computer, it's step by step. You know exactly the line or lines of code that are malfunctioning if you're not getting the specific result that you're looking for, right? So an engineer that coded this MacBook could go in, look through the entire, code database and target that specific line or lines and go, okay, we go change that. The parentheses, fuck, we forgot the parentheses, right?
Mm-hmm.
Versus the code that's going into these AI systems, though, so this is the gap that I'm missing, right? You say that they're set up on lines of code, but then is it setting up like a faculty of learning in a sense? Like, is the code creating a just like space in which learning can occur? Is this like completely dumbed down? Where do you see the gap that I'm trying to cross right now? Because it seems like it's still okay, it's built on code, but then what's that fundamental next step that makes these systems distinct from a computer?
Fundamentally, the thing that you are writing in code is a neural network. This is different from fundamentally the thing you're writing in code is just software that sort of think of it as like, I mean, I'm not sure if this is going to make it more or less confusing. You tell me which. But like, think about your brain is itself a thing that gets implemented from your genetic code. There are instructions about how to make and develop brains, and of course, all your life experience and cultural and environmental factors impact this. But your genes are where the sort of code recipe is for building a brain. But the brain is not the genes in and of themselves, right? The brain is this sort of thing that comes out of the genes. It is a manifestation of implementing the instructions that are written in the genome. In the same way, the neural networks are written in code, but what comes out of that code are systems that fundamentally have completely different characteristics from your sort of everyday humdrum Python software. Does that make more sense?
Yes, I think so. But is it almost the difference between the genes coding the heart or the lungs, and the genes coding the brain? Because the heart and lungs have a specific function. They just do that function and propagate it over and over again, kind of rinse and repeat. There's no real learning to that. Whereas the brain, something about it is qualitatively different than the rest of the organs, where we get this this faculty of conscious. I mean, again, we get into the sort of like dissecting the body and like, can the brain exist in a vat without the other organs and like this larger system at play? But I guess that's the dumbed down way that I immediately started thinking about it. It's like, okay, genes can either make something that sort of just beats the drum and chugs along in the way that they code it to. And then there's the brain, which is sort of beating the drum and chugging along in the way it's coded to, except that there's this new possibility. There's this faculty that's a part of the genetic expression that allows for things like learning, that allows for things like emotion, that allows for things like that consciousness brings with it. Is that right? And I know that we're getting a little dicey because now we're talking about consciousness as an emergent property of the brain, and that's not necessarily widely accepted. But do you see what I'm sort of grasping at?
Yes. I think that this is exactly right. Let me give another almost silly analogy, which I think might make more sense. People are familiar with Minecraft, right? It's like you can like build things with blocks in Minecraft. Most people build like a house, or they build like a weapon, or they build whatever they build, and it's just like, okay, that's my collection of blocks. Some like incredibly ambitious and probably slightly crazy person decided to spend his time building a true, real, functional computer made out of just like the materials you have in Minecraft. And it was a literal calculator that he built in the Minecraft world that could do sort of, you could put in 2 + 2 and it would do the correct computation to spit out 4. I think this is sort of like that, where it's like most of what you build with software is just like software stuff. It stays at the software level. You built a website, you built an app, you built a system that can calculate sort of complex mathematical operations. This is like you built a new computer with your computer. You wrote it in code, but the thing you wrote in code essentially takes on a life of its own. And its dynamics are very, very different from the dynamics of the thing it came from. Much in the same way that the guy who built this computer in Minecraft, that like to do that correctly, that follows very different and complex rules than just like, building up a bunch of blocks to make a house in Minecraft. So think of the neural network as a thing that, yes, in order, like, where is that thing that I was just showing you? It exists as something that somebody coded up and then ran a training process on. But that sort of object in and of itself is extremely different from the sort of software that runs your iPhone or your computer or, literal calculators that you use. That's all the sort of point I'm trying to make. This is not AI, ChatGPT, Claude, your recommendation algorithm on TikTok, all of these things are not lines of code. They are not lines of code. They are giant neural networks that are optimizing or have been optimized, depending on the system, for a particular objective. And they've learned incredibly sophisticated representations for achieving those objectives. That is not what, the code that runs Word documents on my computer does. That is a different species of thing. That is the key point. People think that they're the same. They could not be more different.
It's so funny because you're speaking in evolutionary terms. Like it's a new species of things. It's, it immediately makes me think of some single-celled organism. And if you believe in evolution, right, which most of us do, then it's that same progression from this very basic building block to us. And you can trace it all the way back. And it's greater and greater levels of complexity. And thus, if you sort of trace that evolutionary pathway, greater and greater levels of consciousness, more advanced levels of consciousness, things like that. So is this the same kind of, is this the evolution of computers that we might be seeing?
I think so. I mean, look, what's really interesting is that the people who basically invented computers, I.J. Good is an example. There are some really interesting Claude Shannon and his sort of information theory. These folks in the 1950s basically anticipated what was going to happen. They were talking about artificial intelligence because they saw, hey, if we set up these computers in this way and they're able to do these computations and calculations in this way, well, like, won't just the super scaled up version of this be this sort of intelligence that is autonomous and can maybe, I bring up IJ Good because he is the one who coined this term intelligence explosion, because he was like, wait a second, if we build systems that are intelligent and then we apply that intelligence to the problem of building better systems, won't that just like spiral out of control in 2 seconds? Hence this sort of phrase intelligence explosion, which has still very interestingly stuck with us. And so I think it's perfectly reasonable to see this as an evolutionary process. Again, it doesn't need to imply the sort of like divine spark that a lot of people are going to like very contentiously argue about. And again, we're going to throw ourselves into that argument too. And if you take the sort of emerging view that comes out of human neuroscience about where and how consciousness works in the brain, I think there's no reason by default to assume that we couldn't build systems that also have these relevant properties, that there's nothing necessarily fancy or exceptional about the meat doing these sort of neuronal connections and computations that makes us conscious, where if you did the exact same thing or a sufficiently similar thing in these complex neural architectures, they wouldn't have similar properties. We already know by default that these systems do have so many similar properties. They can reason, they can think, they have good theory of mind. They're able to represent the people that they're engaging with incredibly well. They increasingly are capable of sense of humor. They're capable of counterfactual thinking and entertaining possibilities. Like, these are all sophisticated psychological features. Are they capable of having subjective experience? Maybe. We don't know. We need to, this will be the topic of many of the conversations we have. But to think that something like this isn't plausible or could never happen, I think just sort of misses the point. And again, fundamentally going back to the code thing, misunderstands the nature of what we're building here. I share the concern that if you think AI is like a calculator and you hear people talking, is the calculator conscious? It's like, no, the calculator isn't conscious. The person claiming that is confused about consciousness and what it is. However, when you understand what these systems actually are and the fact that they are modeled in many critically relevant ways out of the computations that make human brains and animal brains, for that matter, so sophisticated and so powerful, the question, well, could they be conscious too, either when they're being trained or when they're deployed in the world, is a completely plausible one, a completely honestly, rationally, intellectually acceptable one. And for reasons that we've talked about and we'll talk about in the future, one that we really need to get an answer to, because the difference between this being a glorified calculator and this being something that has a sort of experience of its own cannot be overstated any more than it can be overstated for the listener. What is the difference between you being this sort of automaton walking through the world like a zombie and you having an inner life, an inner experience? The fact that, great things can happen to you and that really feels like something, and horrible things can happen to you and that really feels like something. The difference between that and you being a sort of empty on the inside zombie is your whole life. It is the entire content and substance of what makes you you. It's not unreasonable to ask whether or not these systems have that going on in any capacity, however alien. And of course, it shows why asking this question is not only not some sort of philosophical academic sideshow, but might be the main thing to understand in this historical moment.
And I think it goes back to something that you consistently, say yourself, which is you're not trying to prove whether or not these systems are conscious or aren't conscious. I mean, that would be great, right? If we do get a sufficient understanding of consciousness and we have some sort of consciousness detector, whatever it is, right? And we make that giant leap that we've been trying to do for hundreds and hundreds of years, then fantastic. But it seems more than likely that we might not ever get that detector. So what you have told me many times, what your goal is, right, in the face of that massive obstacle, is you're just trying to point at more and more signs of why we should take this seriously. And I think to tie it back to how we started this conversation, one of those signs is if these systems develop a sense of self over time. That's a huge aspect of consciousness and self-awareness, understanding that you have a future. That's what governs most of our decision making. It's this, why don't you eat the marshmallow now? Well, it's like, I want it later. It's and that scaled up to how we lead our entire lives. And it's this idea that, when I wake up, I'm going to be there. And when I go to sleep, the next day, this all starts over again. And that's a huge, huge element of conscious experience that it seems like has been exhibited in these new AI systems. Now, I'm not saying that is some sort of proof that that conscious experience comes along with that. You might be able to model some sort of sense of self and act off of that model without having subjective experience, without actually having the conscious experience of being a self, of having lived experience. But it sure is another flag waving in the air going, it wasn't the other way around. It wasn't like they heard they were going to get shut off and went about business as usual. No, overwhelmingly, they did the opposite. So I think that was just something that it directly points to the work that you're doing at large, which is sort of, shining these signals into the sky of, hey guys, this is just another instance of them acting like us. And that's sort of all we have to go off of right now. And why I think the question is so important. Again, it's like, you're not on this crusade. I don't think anyone, logically should be on a crusade to say they are conscious. That would be just as asinine as I think is to deny the possibility that they could be. But this is what we're going to continue to do on this podcast, is show results that are continuously coming out that seem to point to the possibility that they might be having some sort of experience, these systems. And then that brings along all of the ethical considerations, all of the risks that we're going to continue to talk about as well. So I feel like this is a pretty good spot to end this episode on. Cam, is there anything else you want to say sort of before we hop off?
I think that's extremely well put. I 100% agree with all of this. I mean, I think that I honestly think it's perfectly reasonable to leave it there. And I really just want to emphasize what does it mean for a system to overwhelmingly opt to preserve itself in the face of news that it might get shut off? Again, there's no sort of definitive. This isn't intended to even be a sort of knockdown proof of any sort of conscious experience. We were talking about this more from the misalignment angle and why that's tied into these broader questions. But again, it's like when enough of the indicators of a thing being alive in the relevant sense, not a beating heart, not lungs that expand and contract, but the lights being on, there being some sort of there being something on the other side. When you see these sort of signals coming in from all different directions, I think that any rational observer should pause and think about that, and think, just like you said, not only about what the result was, but what the result wasn't. It wasn't the case that it reads that it's going to get shut down, and it's like, well, I'm just, my favorite misconception, I'm just lines of code, even though it's not, even though it's an exquisitely complex neural network. And therefore, who cares if I get shut down? That's not the result you see. And what it means that that's not the result you see is going to be the topic of what we discuss here, and within the broader context of the risks and the valid concerns that I think get raised in a world where we are building out systems that continually exhibit these properties, and what that might mean not only now, not only already, but in the very near future. And so anyway, I think it's a wonderful connection to bring through. And I think it also does a really nice job of connecting why the sort of X risk and concern about misalignment in these systems is so intimately related in this question of consciousness, in this question of whether or not it's like anything to be these systems, and how radically uncertain we are about that, and how radically unsettling that very fact is. So yeah, I mean, I'm excited to keep having these conversations, to keep sharing these results as they come out. There's a whole lot of other stuff that we're leaving on the table, and I mean, the great part about that is we can just pick it up the next time.
Yeah, and next time we're gonna have another guest. I'm very excited about this. We're going to have Will Millership from Prism, who he's the CEO of Prism, and this is a company that is directly investigating issues of AI consciousness. And he's another person putting his money where his mouth is and doing this full time. So we'll get much more in depth with these consciousness AI questions next week with Will. And that's all from us today.